We didn't rehearse this. So what we kind of thought of when we were brainstorming ideas is what was something that we would actually want to play with. And one of our favorite things that all three of us really enjoy is playing foosball. So it's really fun, very interactive. There's kind of a little bit of strategy involved, but it also is a little bit of game of luck. But there's kind of a lot of cons that correlate with the actual real-life foosball table that we most know. First is you kind of always get that ball stuck in the corner, and that always seems to be like really frustrating. Like you put your hand in and move it out, and that's just kind of annoying. Same with kind of ball return. You just have the balls coming out the end after someone scored a goal against you, and it's a little bit demoralizing. So we wanted to come up with a more fun way to kind of re-enter the ball back into play. And then lastly, they're big, they're expensive. We were looking on like Walmart's website. They're even like $600 there. So we wanted to come up with a cheaper way to do that. And ours ended up being about $40, so that was pretty cool. So our target market would be about those 6 years and older. We say 6 years because there are some small moving parts on the bottom, just kind of a choking hazard. But really anyone can play it, from college students, play it with your parents, play it with your grandparents, play it with little kids. So the unique and novel design concepts, we have a couple features. We have corner ramps that move up and down during play, and that kind of adds a new level of complexity and also helps getting the ball stuck in the corner. Also, we have this pinball serve mechanism, so it's kind of based off of how you re-enter a ball during if you're playing on a pinball. So that was cool. And then we also brought in the teams, so it's Purdue and IU, so you'll see that a little bit later. So the play value, it's cheaper than the real version, again, took $40 instead of $600, so that's a nice thing on your budget. Also, it can be played on any tabletop, and you can kind of put it away discreetly. It's not just like an eyesore maybe in your basement. It can travel, you can take it to a friend's house, you can take it to a party. Kids can play with it at a party, so that's kind of nice. And then you can also personalize your team. So we did Purdue and IU, because obviously Purdue's better. But if you wanted to go to a different market overseas, you could make it different soccer teams over there. So it's just kind of got a very adaptable quality to
it. As Kelly mentioned, there are basically three main features to our design. So the corner ramps, which are basically a top-down design with a very basic four-bar mechanism. This is the motion skeleton, as you can see there. And then the re-entry mechanism, as seen in the bottom right, and that's just a simple spring mechanism that we were able to learn how to use in Creo. And then finally, the Purdue and IU players. And so these were created using projection of text onto the players, and then created the Purdue and Boiler, as well as the IU and Hoosier on the players. And here we have the corner ramps in play and throughout the Creo, like, and how they work. So basically, here's if you want to play videos, don't you need to go to the actual. So, oh, there it goes. Thanks. So you can kind of see them, but they're basically moving to about a 30-degree angle. That was basically a good enough angle for us to keep the ball in play. And here's a better look of what's going on with the four-bar mechanism. Very simple in how it works, and then what we decided to do is use a basic servo motor to do this action in our actual design. And then here's also a view from below. So very simple. They attach to the bottom of the field, and then the servo motor is also taking a lot of the weight when it's attaching to the ground. And then I can pass it over to Leslie to go over the next mechanism.
So one of the other key features that Kelly talked about was the re-entry mechanism, which we decided to base off of how you would enter a ball into play for a pinball machine. So that's what the video on the left is, if Sean can press play for me. So they would pull the the pin back, the spring would compress, and then as you release the pin, the ball would be hit and would go through the PVC pipe and then into the field of play. Additionally, we added a scorekeeping mechanism on either end of the field so that you can keep track.
Sorry.
That's okay. Which is the middle video. Again, these are all just Creo simulations, so we're just sliding the score beads back and forth. And then, of course, you have your players that are actually hitting the ball around in the field. So we're just showing a quick video of one of the rods moving in all directions that it can. Once we actually built it, we took a video of it working, and it actually does a pretty good job. And Kelly had some fun running around playing with it while I was videotaping. But it gives you an aerial view of it in real life. So she hit the ball into play, and then we can see the corner ramps moving up and down slightly. You can actually even hear it clicking if you listen close enough. So now we'll give you guys a live demonstration. We first wanted to show you guys the corner ramps by lifting it over.
If you look, you can see the corner ramps moving up and down. Me and Sean are gonna play. Serve it in.
Kelly's at a disadvantage as you run around to the other side. And so there was just an instance where the ball was stuck in the corner and the ramp actually just moved it right back into play. So that's a novel aspect of our design that we were really happy about, that the corner mechanisms worked and they worked professionally. So we'd just like to thank the professor and all the TAs, and we had a lot of help at the AFL and Armstrong building, I guess more cutting the wood and the PVC and the rods to get it all work together. And then those that helped 3D print our parts. So at this time, we would open up the floor for questions. Or yeah, if you want to come look at the ramps or something. Yeah.
Did Purdue just win?
Yes, Purdue.
Yeah.
Yeah. We planned that, not really.
Yeah.
Are you guys just constantly having the motors always turn?
Mhm.
And what is controlled by?
So they don't control Arduino, but they're not running in a circle.
Okay.
They're just doing a servo sweep.
Given your mechanical design of your 4-bar mechanism, why aren't you just having it go in a full rotation?
Yeah, so that's where I just felt more comfortable with using servo motors rather than like a DC motor where it would just be rotating constantly. So that was kind of where I made that decision on just going with the servo motor that would just rotate a short amount of distance to go back and forth. So it was kind of one of those things where I knew that they were super cheap. I got 4 for $12, so it was pretty reasonable to go with the servo motors for this application since we don't need a lot of force out of it or anything like that.
And this design still gives us the same like degrees that we wanted out of it, so it's gonna work.
If you guys have more time, were there any other little embellishments you'd like to add just for fun?
Yeah, I think probably, and this can be depending on if you want to customize it for like different players, but you could put like some goal lines in there, maybe do like more like Purdue and IU decals, but we wanted to keep it like simpler and make sure we got the functioning working before we kind of went on the embellishments, but now that we know it works, okay.
I think something else that we would want to add is a switch to turn the ramps on and off, the power on and off, because right now it's we just have to connect all the wiring and then it'll start working. So I think adding some sort of switch mechanism to turn it on and off easily would definitely be something we want to add next time. Yeah.
You mentioned the cost saving by scaling it down. You said the cost was around $40. There are clearly some advantages to having it full size, right? So what are those advantages, and secondly, what would the cost be if this mechanism were to be scaled up to a full size?
Yeah, so I think some advantages that I can think off the top of my head is that you have more room to play. So for an adult, you know, it's kind of hard to, I don't know, move in small motions. And also there's more players, so there's more rods, so you can move from one end to the other and actually have like an offense and a defense in a larger scale.
Yeah, one thing we noticed too, only having 4 rows, when you bring the ball in, you kind of have to switch your direction that you're aiming at, because originally when the ball comes in, you're facing your own goal, so that's kind of just one thing. So perhaps if we had made it longer and had one more extra row, that might have helped. And I guess scaling it up, I'm not exactly sure how the numbering would work out, probably just have to look at all the materials, but you could probably still make it relatively cheap, probably around $100 if you scale it up to maybe like this table size. It would definitely be a lot cheaper than the regular ones you could buy, because you're not like paying for like the legs, which is another thing. You could just set it tabletop, which is really what we were going for here as a cost saving mechanism.
Really a fun project. Really like it. Can you try to use one sentence to summarize how this design distinguishes itself from traditional toy that we are used to?
Keeps the ball rolling, I guess. Keeps the ball from getting stuck in the corner. So I guess that's a.
Keeping it stuck in the end and having to move it, it's constantly on the feet.
Yeah, and also portable. Yeah.
The one sense that keeps the ball rolling, while adding new features into play.
Yeah, one sentence is a portable toy that keeps the ball rolling.
Yeah.
What's the greatest challenge in terms of assembly? Where do you meet the most resistance?
So in Korea, of course, it works perfectly, and it fits just nice and everything. So we ended up, it's a little too snug on the corners. Like we had to maybe rub it out, like shave it down a little bit more to allow more room so the mechanism could lift up perfectly. And so that we were running into some issues on the design where if we just added, since we glued it, that was another thing. So if we would have maybe used screws instead of glue, I think that would have helped us a lot, where we would have been like, okay, we can just take this and cut the field a little bit bigger, so, or cut these like little corners out, just a little bit more room, so the ramps wouldn't rub against the walls or anything like that. And that is a downfall of the servo motors, is they can't power through those, like the grinding of the wall, because they aren't that strong. So that was definitely the biggest leap to get over for the assembly.
And one other thing I noticed, this being like one of all of our first things we've made in like Creo or SolidWorks, was taking gravity into account. You don't have to do that. And so one thing we were worried